Hello everyone. Today we'll be solving the problem 2 from 2023 Indian National Mathematics Olympiad. So this is a nice problem involving some number theory, algebra and inequalities. So let me first explain the problem to you. So we have 101 positive real numbers a0 to a100 such that all AIs greater than 0 and AIs belong to the real set. So and also they are cyclic. So if we say cyclic modulo 101, so if there is if we have something called 101, it will be basically a of 0. So anything a of 100 plus I would basically mean a of I minus 1. So these are cyclic. So now we are given a bunch of polynomials such that pkx equals to a 100 plus k x to the power 100 plus 100 a 99 x to the power 99 all the way till a of k. So basically this polynomial, and k varies from 0 to 100. So like there are 101 different 101 different polynomials, and depending on the value of k, like because of the cyclicity, it keeps varying, and the coefficients of the powers keep varying. Now we have to prove that it is impossible that each of these 101 polynomials has all its roots real. So we have to prove that the roots of each of these polynomials, like roots of all the 101 different polynomials, each will have 100 different polynomials. So we can't have all of the roots as real for all the polynomials. So let's start figuring a few things out. So since a of i's are greater than 0, so if we have x greater than 0, for any p of k of x will be definitely be greater than 0. So let's now assume that that all roots of all pkx are real. We'll try to contradict this statement. So if all the roots of p of k of x are real, and for x greater than 0 we have p of x greater than 0 definitely, that means all 100 roots of p of k of x are negative. So if so assume the roots of p of k of x are minus alpha k of 0 minus alpha k of 1 minus alpha k of 2 minus alpha k of 100. So these are assuming these are the 100 real roots of p of k of x. So since they are negative, we have alpha k of y is greater than 0 for all I. So and we have the polynomial as this one. So for p of k of x, so using Vieta, the sum of the roots we'll get is alpha k of 1 plus alpha k of 2 plus alpha k of 100 is basically negative of the coefficient of the x to the power 99 divided by coefficient of x to the power 100. So that would give us 100 minus of 100 a of 99 plus k divided by a of 100 plus k. So if we cancel out the negatives, we get the sum of roots alpha k of I is equal to 100 a 99 plus k by a 100 plus k. Now from Vieta, the product of roots will be the coefficient of the zero of the constant coefficient and the divided by the coefficient of x to the power 100. So we'll have a of k divided by a of 100 plus k. Since there are 100 different 100 different terms all with negative, so we can cancel them out because minus 1 to the power 100 is positive 1. So we'll get equals ak by a of 100 plus k. So since alpha ki's are positive, so we apply AMGM on them. So we get by, since there are 100 different, by AMGM we'll get so from here we will get since sum of alpha ki's are 199 plus k by a 100 by k, so we get a 99 plus k by a 100 plus k to the power 100, and the product of roots is a of k divided by a 100 plus k. Now this is for each k. Now if we multiply it for all different k's from k equals to 0 to 100, multiply each of the inequalities we get from them, we'll get something like a of 99 by 100, a 100 multiplied by a of 100 by a of 1, a of 1 by a of 2, all the way till a of 98 by a of 99 to the power 100 greater equal to a of 0 by a of 100, a of 1 by a of 0, all the way till a of 100 by a of 99. Now each of these terms will keep cancelling out, and even here a of 1. So this gives us 1 greater than equal to 1. Now 1 can definitely won't be strictly greater than 1, so 1 is equal to 1. So if for at least one k, if we have uh, strict inequality, that is for at least 1k we have strictly greater than ak by a 100 plus k, that would it would actually mean, it would mean that 1 is greater than 1, which is a contradiction. So that means for each k we'll have a of 99 plus k by a of 100 plus k is strictly equal to a of k by a of 100 plus k. Now this comes from the AMGM inequality, from the AMGM inequality. So that would basically mean for each of the roots, it would mean this equality holds, and we know AM equals to GM only when all alpha ki's are equal to each other. That is, all the roots alpha k1 equals to alpha k2 equals to all the way till alpha k 100. So they are all equal to each other, that is alpha. So for from here we get for each k each k 100 equal roots, 100 equal roots, all alpha k. So now we can get, if we take the sum of the roots, minus 100 alpha k is equal to minus 100 a 99 plus k by a 100 plus k. So we can cancel minus 100 minus 100. So all the roots are equal to a of 99 plus k divided by a of 100 plus k. Now if we use Vietas and take roots 2 at a time, that would give us, if we take 2 at a time, so there are 100 C2 different combinations and all are equal, so we'll get 100 C2, and since the roots are equal to a 99 plus k by a 100 by k, so we get a 99 plus k a 100 plus k whole squared. And we also know that it is equal to the coefficient of a to x to the power 98 divided by coefficient of x to the power 100. So from there we get x to the power 98 plus k a to the power 100 plus k. Now if we multiply for all k, if we multiply this relation, we get 100 C2 to the power 100 multiplied by a 99 plus k by a 99 plus a 100, then a so you can kind of see where this is going now. A1 A0 is equal to a 98 by a 100 a 99 by a1 so again all of this will cancel out with each other. So we get that 100 2 by 100 is equal to 1, which is a contradiction. So, so, so basically by contradiction we have proved our first assumption. So our assumption that all roots of p of k are real. So this assumption is false. So hence we are proving that is impossible that each of these 101 polynomials has all of its roots real. So this was the solution. Hope you like it. If you love this video, please don't forget to like and subscribe. See you next time.